So we've talked about two different ways currently to solve quadratic equations. And when I say solve, that means that I'm finding the solutions, the x-intercepts, the roots, or the zeros. All four of those mean the exact same thing. So the first way we've talked about is to use factored form or factoring. And if I'm going to use factored form, that means I have two parentheses, x plus or minus something, x plus or minus something. And I want to solve that. All I have to do is take each factor, set it equal to 0, and then solve for x. And I can find my two solutions from there. Now the other way is what we've recently talked about, which is solving using square roots or radicals. And so there's two options that we have when I have to do this. First of all, I want to ask to see if the equation, if my quadratic is in factored form or if it's in standard form. If it's in factored form, then I can just set each factor equal to 0 and move on. If it's in standard form, I have to ask myself, is there a b value? So is there a b of x, a linear term? If the answer is yes, there is, then I can factor that equation. And the way that I factor is I make sure that it equals 0, that my x squared value is positive, and then I just solve each factor after using bottoms up. If there is no b value, that's where I can go straight into using square roots to solve. So let's look at the first warm-up problem. I notice that it's in standard form, but it does not equal 0, so my first step is to make this equal 0. So I'm going to move the 2x and the 5 at the same time, just by using opposite operations, to give me x squared plus 6x plus 5 equals 0. Now my equation equals 0, and my x squared version is positive. So I can put this into the bottoms up form. I've got a times c, so 1 times 5 at the top, my b value at the bottom, 6, and I'm going to divide each factor by 1. So I need two numbers that'll multiply to give me 5, that add to give me 6. So I'm going to use here 5 and 1. So as I get ready to write these factors, use the swing method, 1x plus 5. The denominator swings back to go with the variable, and the numerator swings forward to become my constant. And 1x plus 1. Well, then we know we set each of those things equal to 0. And I can find my solutions here where x will equal negative 5 and x will equal negative 1. As I'm looking at the second problem, same thing. I notice that it is in standard form, but it does not equal 0. So I'm going to move each of these things all at the same time. So it's positive 3x squared, so I'm going to subtract. Positive 9x, so I'm going to subtract. Positive 5, so I'm going to subtract there as well. This whole side will cancel, and I'm left with 2x squared plus x minus 1. I'm sorry, minus 3. Because 2 minus 5 is 3. At this point, I can check and see, yes, that does equal 0. My x squared value is positive, so I'm just going to put that into my bottoms up. So I have 2 times negative 3 at the top, which gives me negative 6, and then a positive 1 at the bottom. I also have to divide each factor by 2. So I need two numbers that will multiply to give me negative 6, but when I add them together, they give me positive 1. Those two numbers will be positive 3 and negative 2. Remember, I have to simplify when possible. So this side will simplify to be negative 1 over 1. And this side is as simple as it's going to get. So my two factors will be swing method 2x plus 3 and x minus 1. I set each factor equal to 0. And so for the first one, I'll subtract 3. So I'll get 0 minus 3 is negative 3 divided by 2. So negative 3 halves. And then x minus 1 equals 0, so I add 1 to each side. So my two solutions here, or roots or x-intercepts, is x equals negative 3 halves and x equals 1. Now, as I look at number 3, is this problem in standard form? Yes, it's in standard form, but I do not have a b value. And so if there is no b value, all I have to do is try and isolate the x squared. So if I do that, I'm going to subtract 22 from each side. I have 2x squared equals 128. Then what I'll need to do is divide each side by 2. So I will have x squared equals 64. And then to get rid of the x squared, simply take the square root of each side. Now remember, when we take the square root, there are always 2 answers. There's a positive and a negative 8, because 8 times 8 is 64, and also negative 8 times negative 8 is also 164, or equals 64. For number 4, standard form, but there is no b value, so I'm simply going to isolate x squared, and do that by adding 10 to each side. I get x squared equals 20. So to get rid of the x squared, take the square root. So here I'll have x equals plus or minus the square root of 20, but we know from our simplifying radicals lesson that I cannot leave it square root of 20 unless simplify. So factors of 20 are 4 and 5, and factors of 4 are 2 and 2. So I have a pair of 2's and a 5 left over. So my final answer for number 4 will be plus or minus 2 on the square root of 5. Remember, I have to have a positive and a negative version. With 5 and 6, it's pretty simple to know that I just need to use the square root method, simply because it's not in standard form, it's in vertex form. So I want to try and get the parentheses isolated to get rid of the squared. So I'm going to start for number 5 by subtracting 25. So I have 3 times x minus 4 squared equals 75. Then I want to divide each side by 3. So I'll be left with x minus 4 squared equals 25. At this point, it becomes a problem like number 3 and number 4, where all I need to do is take the square root of each side. So I'll be left with x minus 4 equals plus or minus the square root of 25, which is 5. So I'll have to set them separately. X minus 4 equals 5, and x minus 4 equals negative 5. If I add 4 to the first one, 5 plus 4 equals 9. And if I add 4 to the second one, x will equal negative 1. Number 6 is a similar problem. I don't have to do a subtraction to start with. Simply divide each side by 5. So I have x minus 1 squared will equal 40. Then I want to take the square root of each side. And when I do that, I'll be left with x minus 1 equals plus or minus. Now I'm going to use the square root of 40 here, but I need to simplify. So factors of 40 are 4 and 10. 4 are 2 and 2, and 10 is 5 and 2. So I have a pair of 2, so plus or minus 2 on the square root of 5 times 2 left over, which is 10. Now when I get ready to do this, I need to make sure that I set them, because I have a radical here on 2 on the square root of 10, and I don't have a radical when I add 1. I can simply just add 1 to both sides and leave it plus or minus 2 on the square root of 10 plus 1. So now we're going to add in a third option of how to solve these quadratic equations. This third option is going to be something we've already talked about, and that's completing the square. But when will this work? And the thing with completing the square is it's going to work anytime I have a quadratic equation, even when it's not factorable. I have to be careful here. I can go back and just use the square method when there's no b value. But the great thing about completing the square is that you can do it even when there is a b value. So let's recap on how to complete the square. So if I'm going to rewrite these equations in vertex form by completing the square, my first step is to group my first two values. So x squared plus 20x is going to go in parentheses, while plus 50 goes off to the side. So I know that I'm going to have to complete that square of 20. So I'm going to take 20 and divide it by 2, because remember, when we complete the square, we want half the b value. So half of the b-value is 10, but the whole point of completing the square is to square that number. Well, I can go ahead and rewrite this first part in my vertex form because I know what half of 20 is, which is positive 10. So I have x plus 10 squared. Now I have to keep my equation nice and balanced. So if I add 10 squared, which we know to be 100, then I need to also take off that 10 squared to keep our equation nice and balanced. So 10 squared is 100, but if I added 100 right here, to keep it balanced, I need to make sure that I subtract 100. So at this point, all I want to do is combine like terms and simplify. So y will equal x plus 10 squared, and then 50 minus 100 is negative 50. So if we follow those exact same steps for number 2, I'm going to group my ax squared and my bx values together, and then I'll leave my plus 11 on the outside. Like this here. Now I do notice that 2x squared and 8x have something in common, so I want to factor out a GCF here. So I'm going to say they both have a 2, so 2 will go on the outside. 2x squared plus 8 divided by 2 is 4x, and then I'm going to have to fill in my c value. So what I want to do is take my new b, which is 4, and find half of that. Well, half of 4 is 2. So I will square 2 squared. The things I have to be careful here when I go to rewrite this, I have 2 times x plus 2 squared plus 11. But when I do this last value to keep things even, 2 squared is 4, but remember I have to factor in that 2 that I pulled out. So 4, which is here, times 2 is 8. So I want to subtract off 8 because 2 squared is 4, but again, I'm multiplying that by 2. Then I simply just combine my terms. So we have 2 times x plus 2 squared, and then 11 minus 8 is positive 3. This is just a review on how to complete the square. We're going to use these exact same steps. The only thing is now we're going to have something behind the equals. It's not going to equal 0. We have some steps in the box to remind us what to do. It's going to be the exact same process. So I start by grouping my ax squared and bx values together. So I have x squared plus 10x plus something. It's going to equal plus 25, and the whole thing equals 10. So I still want to take half of my b value. Again, I have to pull an a value out because there's no GCF between 1 and 10. So 10 divided by 2 will give me 5. So 5 squared goes in that part there. Now, 5 squared we know is 25, so to balance my equation, I've got x plus 5 going in parentheses. I had my plus 25, but I want to subtract it. I'm going to rewrite this as 5 squared so you can see where this came from, which is right here. I added it in, so to keep things balanced, I need to subtract it off. This whole thing is going to equal 10. So far, I've done nothing except for balance the equation. Now, all I have to do at this point is simplify where I can. So, x plus 5 squared is going to be plus 25 minus 25, which will equal 10. We know if we can combine 25 minus 25, that is just going to go away to be 0. Now I have a problem like we've done before, which we did in the warm-up. I just need to square root each side. So for this problem, I have x plus 5 equals plus or minus square root of 10. And then when I simplify it, because square root of 10 does not match with 5, I'll simply have x equals plus or minus square root of 10 minus 5. That'll be my final answer. For number 4, Go back, follow our steps exactly the way we see it. Group my ax squared and my bx values together. So I will have x squared plus 8x plus blank, and I have plus 2 equals 0. So what goes in the blank is I want to make sure that I take half of my b value, so 8 divided by 2, 4. Remember, I have 4 squared that goes here. So because this equals 4, it's x plus 4 squared plus 2 came from the problem. But if I added in a 4 squared, which is 16, then I must subtract that off. So I'm going to leave it as 4 squared so you can see where that number came from. Then we must simplify. So x plus 4 squared plus 2 minus 16 equals 0. Combine these two like terms. X plus 4 squared minus 14 equals 0. Well, now I can see that there's no b value, so I'm just going to go back like in the warm-up and solve. So I want to add 14 to each side. X plus 4 squared equals 14. Take the square root of each side, because now my parentheses are isolated. So x plus 4 equals plus or minus the square root of 14. I know that I can't simplify 14 because the factors are 7 and 2, no pairs. So all I have to do to write my final answer will be x equals, and I'm going to subtract 4 from each side, plus or minus square root of 14 minus 4, because I have to subtract 4 from each side. For number 5, same process. I want to group my ax squared and my bx values together. So I'll have x squared minus 4x plus a blank, because I've got to complete that square, plus 10 equals 42. So I still want to come in and take half of my b value, so negative 4 divided by 2, which will give me negative 2. Then I want to square that to complete that square. So inside my parentheses, I should have x minus 2. And again, it's negative 2 because half of negative 4 is a negative. That's squared. I have my plus 10 from the problem. But I want to balance it by subtracting negative 2 squared. The whole thing is going to equal 42. So x minus 2 squared plus 10 will be subtracted by 4, because negative times a negative makes a positive, equal 42. So I have x minus 2 squared plus 6, and that'll equal 42. Well, to solve this problem, I will subtract 6 from each side. So I'll have x minus 2 squared equals 36. Then I'm going to want to take the square root of each side. So x minus 2 equals plus or minus, going to have two answers, 6. So x minus 2 equals positive 6, and x minus 2 equals negative 6. If I add 2 to both sides here, x will equal 8. And if I add 2 to both sides here, x equals negative 4. Those are my two solutions. For the last two problems, notice that there's a difference. It doesn't start x squared anymore. My a value is no longer 1. But I still follow the exact same steps. So I want to group my ax squared and my bx values together. Now if I look here, I notice that I have something in common between 4x squared and 8x. So I'm going to take out the number, the GCF that's in common there, which is a 4. So when I factor out a 4, I'm left with x squared minus 2x. I'm going to complete that square. And then I still leave everything else in the problem minus 32, and that's going to equal 0. Well, to complete the square, I need to take half of negative 2 to give me negative 1. So negative 1 squared. Now I can't forget about the 4 on the outside, it has to stay there. So I'll have 4 times x minus 1, because when I divided negative 2 by 2, I got negative 1 squared. And then I have minus 32. But when I go to fill in my last part to subtract off to keep things nice and balanced, I have to remember that I am multiplying 4 by this negative 1 squared as well. So I'm going to subtract off 4 times negative 1 squared. And as I go through to simplify, I'll have 4 times x minus 1 squared minus 32 minus 4 equals 0. Well, negative 32 subtract 4 will simply give me negative 36. Now I'm set up to solve just like we did in our warm-up problems. So I'm going to start by adding 36 to each side, where I have 4 times x minus 1 squared equals 36. Divide each side by 4. So I have x minus 1 squared equals 9. At this point, take the square root of each side. So x minus 1 equals plus or minus the square root of 3. So x minus 1 equals positive 3. X minus 1 equals negative 3. So if I add 1 to both sides, x will equal 4. And then add 1 to both sides, x equals negative 2. Finally, for number 7, still working in the same process, group my ax squared and my bx values together. I noticed they have something in common, so I'm going to take the GCF out. Remember, I don't really want to take the x out here because I'm trying to complete the square. So I'll take a 2 out, and I'm left with x squared minus 6x. Complete the square with something. Then we have minus 10 equals 44. Remember, I'm taking half of my b value, so negative 6 divided by 2 to give me negative 3. So negative 3 squared has to go there to complete the square. Because it's negative 3, it becomes 2 times x minus 3 squared minus 10. But remember, to fill in the blank, I have to subtract. I can't forget about the 2 on the outside. So 2 times negative 3 squared. That'll equal 44. We want to simplify. So 2 times x minus 3 squared minus 10. Negative 3 squared is 9 times 2, which if we subtract 18, equals 44. At this point, we have 2 times x minus 3 squared minus 28 equals 44. Add 28 to each side. And I'll get 2 times x minus 3 squared equals 72. Divide each side by 2. So I'll have x minus 3 squared equals 36. At this point, the parentheses are isolated, so I can take the square root of each side. I have x minus 3 equals plus or minus 6. X minus 3 equals 6. X minus 3 equals negative 6. We add 3 to both sides, x will equal 9. Add 3 to both sides here, and x will equal negative